In this video, let us understand what are different boiler accessories, what is the need of boiler accessory, and the one or two example like a desuperheater and the superheater as a boiler accessory. So boiler accessory, what are boiler accessory? Like when we get the mobile, we increase its efficiency by having the tempered glass, guard, etc., right? So that is not necessary for the functioning of the mobile, but we use those extra items on the mobile so that we can increase its performance data, right? Similarly, in the boiler, many accessories are used to make the trouble-free functioning, and this also increases the efficiency of the boiler, right? um, Two items we generally speak in the boiler. One is a boiler fitting, one is accessory. So fittings are required for the better performance. Here accessories are required to increase the efficiency. So high economy in the power generation can be achieved by utilizing heat energy to the maximum extent. So the heat energy what we are going to get can be used for the maximum extent. Generally, the typical heat utilization of the boiler furnace is of order 70% only. Means rest 30% will be left to the atmosphere or sink so that it cannot be recovered. This means that the 30% of the heat carried by the exhaust gas, which is a huge loss, so if discharged directly to the atmosphere. The various means to recover the part of heat energy are: one is superheater, reheater, economizer, and aerator, and we can have uh, deaerator, right? And there are other applications, but let us concentrate on these accessories mainly. The temperature of the hot gases burnt in the furnace are of the order 1200 to around 1350 or 1400 degrees centigrade. Means the huge heat has been generated, right? So the around 70% of the heat is utilized by the furnace tubes, right? Different water tubes are there: furnace tube, wall tube, right? Then superheated tubes, and still there is a 650 degree centigrade temperature. So the rest of the heat is utilized in the superheater, reheater, economizer, and aerator. So the first one comes is a first in a path. The first one comes is the superheater and reheater, then economizer and aerator. So when the flue gases pass out of the superheater, reheater and economizer, the temperature is brought up to 400 degree. Earlier the temperature was 1350 or say 1400. Now it has a 1000 degree. If I am using all the 4000 degree has been recovered and 400 degree still there in the flue gas. The heat available from these gases are utilized for aerator and can be brought 160 degrees centigrade. That also depends on the sulfur content of the fuel, right? As we discussed in the earlier videos, the dew point and the sulfur content plays a very important role to decide what is the temperature that I have to exist the exhaust gas, right? If the flue gas is having less sulfur, so flue gas is having sulfur means in turn I'm telling the fuel is having a less sulfur, right? So I can dump around 120 degrees centigrade, but if the sulfur content is high I cannot dump. Generally the solid fuels or the fuel like the coal fuels, right, have to dump. Generally, it is dumped at around 150 to 160 degrees centigrade because it has got the sulfur content. The other essential accessory includes a desuperheater, soot blower, right? These are and deaerator. Deaerator is used to increase the temperature of the water. Let us discuss what are superheater. As the name implies, the function of the superheater is to supply the superheat, right? So here we have got three temperatures. One is the sensible heat, then comes the latent heat. This is a sensible heat, then comes the latent heat. Then anything more than latent heat is a superheat. So this region, whenever I am using the function of the superheat to get the superheater temperature, so that my dryness fraction will be around at around 1 only. The steam generated in the boiler is not fully saturated. It contains some water particle, that is mentioned as a quality of the steam, or dryness fraction is it is always less than 1. If used directly, the water particle in the wet steam cause corrosion in the turbine blades, right? The turbine is moving with a particular velocity, and velocity compound we have studied in the turbo machine, that plays a very important role. So the water particle will damage this the velocity profile. So the life and later failure of the blade will take place. So in the sketch you can see, right, from the steam drum, the tapping has been taken out from the boiler drum, and this is the superheated tube where it comes in contact with the flue gas. Then the superheated steam will be moved to the prime mover, in this case a turbine. So that is a very important role it plays. So the superheated tubes looks in like this one. It is in a bundle which is generally hanged on the roof. Earlier, one or two models where it has been placed at the furnace also there, but they have found some defect or it is not giving good performance. Therefore, nowadays you find the superheated tubes hanging on the roof of the furnace. The superheater completely saturates the wet steam and increases its temperature. Superheated steam has high heat content, hence has an increased capacity to do work. This in turn improves the overall efficiency of the power plant. So the superheater tubes are made up of steel, and it is of 25 to 50 mm dia, and it is a U-shaped. So some packing of EN material will be provided between the two tubes because it can bend very easily. The superheaters can be classified based on the heat transfer method. So they are as follows: convective heat transfer superheaters, then we have got radiant superheaters, right? In the radiative superheater, they absorb the heat by radiation, right? And these are generally located at a radiant zone of the furnace. And combined convective and radiant superheater, which absorbs both convection and radiation of the hot gases. So it is called as a pendant superheater, and another secondary superheater is used as in a steam power plant. The desuperheater maintains the required temperature of the steam after passing through the final stage of a pendant superheater. So we have not studied desuperheater. In the next slide, let us understand what are meant by desuperheaters. Reheaters. What are reheaters? In the Rankine cycle, right, we have studied a bleeding or bleed type turbine, or one more is a reheaters. So in the HP turbine, after certain stage of its expansion, a tapping has been taken out from the turbine and it is reheated and sent to the LP turbine. So this see, we know that as the expansion works goes in the turbine, its quality of the steam or dryness fraction drops down. This is very serious because it will increases the corrosion. Moreover, these turbine blades, right, impulsive blades are imported and they are costly enough. So no user want to take a risk on this one. So it has to be the more than the quality of the steam should be around 0.85. If it is 0.9, it's much better. And the supervisors or the staff, the engineers always monitor this quality or the dryness fraction, so that they don't want to drop this dryness fraction to such a level that it will give a bad effect on the turbine blades. Therefore, a tapping will be taken from the HP turbine and it has been sent, right, it is sent to the LP turbine after rating. So in the boiler, the superheated are used to superheat the steam before being expanded in the HP turbine. The steam from the HP turbine loses the pressure and temperature. The steam before being sent to the next stage, that is LP turbine, it has been improved again. So reheater is not always advised because it increases your cost. So it has to be justified in a particular manner. So say at a 150 bar and above boiler working, reheaters are used. Otherwise it is not justified. So financially it is not justified because it will increase the cost, right, initial cost, and I have to provide the pipelines, insulation, all those things. So thus the reheater is similar to the superheater except that it adds heat to the steam coming out of the HP turbine before being expanded in the LP turbine. A reheater is generally located above primary or convective superheater in the path of hot flue gases. It is made up of steel tubes mounted horizontally perpendicular to the flow direction. So here you can see the sketch of a reheater. So steam from the turbine, here it enters and get reheated, right, in the passage of the flue gas, and it has been sent once again to the IP turbine. Desuperheater. Let us see what is a desuperheater. It is essential to control the superheated temperature. See, sometimes the temperature shoots up and it becomes overheated. So if it is overheated, my metallurgy of the turbine blade will be impacted. I don't want to have the bad impact on the metallurgy of the tubes. That's why it has to be maintained a particular temperature. Device that is used to control the superheat temperature are termed as desuperheater. The various methods are used. One is bypassing the hot gases. When the temperature of the superheated steam rises sufficiently high, then the hot gases are bypassed with the help of damper. So they get a damper and it can be controlled either by your computer system, right? The damper can be operated on or off. So by this way we can control the temperature. So second one is you are going to spray the water, right? Water spray. Here you can see there is a water spray has been done in the bundle of tubes. This is also possible, right? And this is one more method. And tilting the burner, the direction of the burner can be tilted. So you just tilt it by a certain angle so that the temperature or the heat content temporarily not taken by that tube. Then another method is controlling is by using the desuperheater is that is using water. What we have just seen in the earlier sketch, you spray the water in a particular form right? It's not in a water in the pressure, in a mist, at least of course in a pressure, but not in a tap water, right? You are going to spray in a particular pattern so that the steam temperature comes down. Then immersion in the steam drum. This is one more method where we are going to immerse the coil in the water so that the water the steam temperature comes